Hey, good morning. Thanks for coming in. How are you today? It's a Friday. You should have been overloaded already with a lot of new terminologies, 5G, cloud native, open, right? So I don't want to have yet another dose of jargons, but I'll try to keep it simple and more interactive. So let me start. So as the topic suggests, I'm trying to simplify the whole infrastructure, 5G, Kubernetes, cloud native, all of it, and provide you in a simple, easily consumable way, right? So of course, I'm going to give you like 10 minutes of a Q&A session. So if you have questions, please bear with me until the end, and definitely we'll have a good discussion at the end of the session. With that, let me start the session, right? Quick show of hands. How many of you feel I know 5G? Oh, okay. Kubernetes? Fantastic. How about the telco architecture? Awesome. Cool. That makes my life simple. Okay. So 5G has been, it has been in discussion at least for the past 3 or 4 years, but now it's around the corner, right? The first specification that came from IMT was way back in 2015, where they say their view or their vision for IMT 2020. And then they said what type of workloads would there be in real life, and would the network be ready for that, right? So we are right across the corner, as I was mentioning, 2020. Let's see how much of those use cases are there, whether the network is ready or not. So before I jump into it, we have come through a journey, right? We are truly in a disruptive world wherein everything is a service, right? For example, Uber, you would have never thought around 2 years back that you can go around the place without a car, right? So the whole concept here is the whole IT infrastructure has essentially opened up so much that you can start any business without even having much of an investment, right? So that's possible because of clouds. I call it as Cloud 1.0. Then we do have the Cloud 2.0, which is Edge. I'm also going to touch about it. Then we are talking about self-organizing network. And last but not the least, DevOps, right? All of it, in a way, is needed to realize a 5G network, right? Pretty much, these components, whatever I was explaining to you, has been well used by the enterprises or the web scale companies, right? For example, take Google. If you look into Google architecture, most of the infrastructure they are built not from servers, but from white boxes or custom-made hardware, right? And then they are known to fail. What they have is the software component has the intelligence in order to take the failure, and that's where the self-organizing network plays an important role, right? So all of it that has been in web scale companies now are coming to telco world to realize what we call as a 5G dream, right? So let me get into a bit of further details. We say transformation, right? The transformation is real. Why is it real? First, the service innovation, right? If you are in Bay Area, you already would probably in a week, you'd probably bump across self-driving cars twice or thrice, right? So what it means is these are all new service. It's a service innovation, which is essentially changing the whole 5G world, right? So one is the whole 5G concept. Another one is the services that are going to be enabled via the 5G, right? So what's going to happen is we are going to look at new services which would be composed based on existing services, right? Just to give an example, Uber created the platform of delivery. It started with a cab as a service. Now they are moving towards a concept called Uber Eats. They're also moving towards another concept called Cloud Kitchen. The bottom line is it's single service, but what they are trying to do is they are trying to create new services based on the existing service. So that is what we call as the service composition. Moving on to the transformation, right? So when we talk about transformation, there has to be true dynamism. How many of you have wondered how Uber is able to get you a car within few minutes? Anywhere in Bay Area, if you order, or anywhere in the US, you are able to get it in less than 10 minutes. How is it possible? Has anyone thought about it? Okay. So they do zone the cars. They do a geofencing, and then what they do is they ensure that a car that enters into the geofence would essentially cater to that of that particular region. By that, at any point of time, they know how many cars are available, and then they will be able to match to that of the customer needs. Right? The reason is geofencing is quite a concept that was introduced by Google, particularly if you're familiar with Pokemon. They use the concept of geofencing to, in fact, create the whole virtual world. The most important thing here is the whole concept of realizing the geofencing calls for a lot of transformation in the infrastructure, right? Which means even though we are geographically distributed, it cannot be treated as silos. It has to be joined together, right? Number one, with that, what happens? The whole globe becomes a single platform for me to operate, right? Just to map it to that of a real-world technology, you would have heard of a concept called Knative. Have you heard of Knative? Okay, you would have heard of Istio, right? So what is Istio is essentially we call it a service mesh, which means I have services and I can mesh it together. Knative takes it to the next level. What is meant by next level is, take for an example a Macy's or any enterprise retailer. He has basically many components. One is essentially his point of sales. Another one is his infrastructure to process all his inventory. The third one is essentially manage the inventory between centers. So you see that it's a quite complex infrastructure. Across the US, they have many shops. Of course, it's shrinking thanks to Amazon, but assume that there are a lot of shops, right? So now what's happening here is they have data centers that are at different parts. When Amazon started it, you have the concept of availability zones, right? So what is meant by availability zone? You basically instantiate cloud next to your region so that your access time is shorter, your RTT is shorter. Now with architecture like Knative, what happens is it brings in a different type of solution to the whole problem. What you can do is you can mesh all of these across your, say, region, and then you can intelligently route the request or traffic depending upon the load. For example, if Midwest is less loaded, and if the West is highly loaded, they can intelligently route traffic to the Midwest so that they can load balance, right? The reason I'm telling you is because the whole transformation cuts short the silos. Now, to realize it, you need to have the patterns that would essentially cut short. I'm going to touch upon some of the concepts around it. And the other important thing is, gone are the days wherein the businesses will come and ask IT, can I implement it? Or they go to a vendor and then say, hey, what are the features that are available down the corner or in your next release? Now, what's happening is the business wants its requirements to be met. If it's not met by the vendor, it would be done by themselves. Take Netflix, take Google, any of the enterprises, right? The whole essence here is everyone has started talking about intent-based. What is intent? The business says, hey, I want to have this particular business functionality. You just define it. Behind the scenes, the whole infrastructure is created for you for that particular intent. Why it is relevant? Some of the use cases in 5G needs intent-based. And that is where the digital transformation that is intent-based is very, very important. Last but not the least, optimization. What is meant by optimization? For example, if you're a service provider, on one side, you have your user needs increasing, the number of connected devices. Just a wild guess, each one of us, by 2020 or 2022, guess how many devices we would have? Each home, each connected home, how many devices? Just a number? 100. That's a good number. I mean, we cannot deny the fact it can be 100. Imagine the load on your network. Is the network changing? Is the service product laying new cables? Is he upgrading his infrastructure? It's the same infrastructure, but my user doesn't care about what the infrastructure has, right? That's one side. On the other side, if you're dependent on vendor, what is the typical lead time before you put a request and it is in the product? 6 months? An year, right? So now what I'm in the middle, already my revenues are shrinking. What do? I need to look at new ways of making money, which means I need to enable new service. If I have to enable new service, I need to have my infrastructure meet those new requirements, right? So that is where more and more stress is going on towards having the infrastructure being efficient. The other one is essentially also the resources are getting commoditized. And then also this is going, the more open you are, the better it is, because you have better control on the whole infrastructure. And then the last important thing is it is going to be truly heterogeneous, right? It cannot be just one type of network function. It's going to be heterogeneous, right? So the transformation, if you're ready for the transformation, you are basically enabling yourself to open up to new opportunities. With that, let me just give a quick snapshot of what are the different types of applications that would come to the network. Vehicular telematics. Even though when automated or self-driving cars came in, people were assuming that the self-driving cars would depend on the network. But they are not dependent. They are autonomous in nature. That is why we are talking about autonomous cars. But the telematics, the data, the information, all of this has to be fed into the network for processing, or to the data center for processing. Drones. Already Uber is trying a drone-based delivery system, meaning even including they are looking at a flying car, right? Big data is a well-known thing. Internet of Things, not just for your homes, it's going to be IIoT, which is industrial IoT, which means massive amount of sensors. Then the other use cases are pretty known. But broadly, this can be categorized into 3 areas. One is ultra-reliable low latency, wherein this we call it as a tactile internet. This particular use case is you have the application that would essentially be expecting that it has a turnaround in a much more faster way. To give an example, people are talking about e-surgery, wherein the surgeon would essentially be in a remote or in his office, he would be able to perform surgery on a patient who is somewhere down the lane, right? So here we are talking about really low latency. The next one is essentially enhanced mobile broadband, which is well known. The third one is essentially massive machine-type communication, when machine-to-machine communication is going to be massive. Even with respect to industrial IoT, we are talking about a lot of data. With that, let me get into, this is the IMT 2020 I was talking about. This is the one that was put in by the ITU. So in this particular slide, I just want to categorize the type of these services, right? Now, when we talk about ultra-reliable low latency, we are talking about jitter sensitive. I cannot have a delay. When a surgeon expects it to cut, it has to cut in real life, right? And let's assume it's a digger, he has to dig, okay? More than e-knife, e-digging is common, right? You have to dig at the right place. So massive IoT is all about reliability sensitiveness. The third one is about, the enhanced mobile broadband is about bandwidth sensitive, right? Now you see that these are the 3 quite varied use cases, right? In the particular triangle, you see that capacity, on one side, the massive connectivity, on the other side, and the third one is essentially the low latency, right? How am I going to realize it? The same network, nothing changes. What do? Let's take a simple example. Can I realize ultra-reliable low latency with my existing network? If you're from telco, you for sure know the architecture that your core network functions are present in your cloud, or in your data center, or in your central office. Your radio base station are far along. What would be the round trip time? Is it 1 millisecond? 2 millisecond? No, right? It's probably around 30 milliseconds. Can I afford to have 30 millisecond round trip time? No, I'm done. What do I do? Okay, so that is where the concept of edge comes into picture, wherein in your network functions, what you do is you bring in certain network functions closer to that of your user. The idea here is how soon you can break out to that of internet or to the network where you have the operations to be performed. So what's happening is that's where the whole concept of network slicing comes in. Network slicing is all about slicing and dicing your network functions and attaching it or making it application aware, right? Which means what will happen is if you look at typically what will happen is I will have for the certain functions, I'll create a slice wherein the network functions will move closer to that of my end user. By that, I can break him out, right? So these are the most important, awareness you need to have when you go and design your network. Given the fact, I've just simply said, move your network function. For people who are dealing with network function day in and day out, it's not so easy. There is compliance, there is bring up, all of those factors comes into picture, right? Now, what it means is now I have to look at my whole infrastructure as composable, which means I know I have a predefined edge site. On a click of a button, the edge has to come. It has to be provisioned with all the network functions, and then it has to be connected back to my core cloud as well as to the radio, right? Let's look into it. So this is how the next generation will look like. 5G is the beginning, right? So what you see is the most important thing is there is a concept called cups, which essentially what happened was in the erstwhile architecture, for example, 3G, the radio component, the RAN, essentially contains two things. One is called the radio head, okay, and then the base station, which is called the BBU, which is called baseband unit, right? These were all together, right? Now with a lot of standardization as well as there are things that are opening up, which is essentially making the radio network to be quite distributed. What it means is also the most important thing is with respect to 5G, we are talking about MIMO. We are talking about beam formation. We are talking about multi-tenancy. What it means is there are two parts to it, let me tell you. One concept is called your macro cell, where you have big radio station and then, your radio antenna, and then you're trying to provide a service to a region. And another thing is called small cell, which is essentially you'll have a bunch of cells, but the control unit would essentially be closer to that of your, closer to where, you can essentially move away from that of your radio location, right? So that is where the concept of front haul, mid hauling comes into picture. But this is just to depict how the whole network would look like, which means you have the UE, which is essentially, it's not just your mobile phone, it's going to be anything like premises. Then you have the front haul. Then you can have MEC depending upon the type of service you're going to offer. Then you'll have the backhaul, and then you'll have the core cloud, which is essentially your typical location where you have your EPC hosted, right? EPC along with your core data center that is hosted, right? But nevertheless, there are a few things which I want to highlight. The network has to be adaptable. It has to be really scaling. It has to be programmable. It has to be cloud ready. When I say cloud ready, not that you host it in a cloud, but it should be cloud native, right? And then other things I think we have covered up. This is just to give a snapshot. I'm not going to get into the details, but this is how it's going to be. As I was mentioning, you have the RU, the DU. As you see that it hosts both the macro as well as the small cell. You have the base station to control it. Then you have the edge cloud that sits in. So these are some of just components of 5G. I'm not going to get into the details, but just a quick snapshot. Also, this has to be programmable. Until now, the interfaces have not been opened up But with SDN-R, there are many things that's happening as we speak. One is essentially the ORAN. You would have attended sessions during the ONS. You also have open-R interface, wherein they are publicizing their own network functions which are open. And then you have SDN-R, wherein these radio devices, they open up netconf interface. There is a new specification called mplane, wherein they open up the netconf interface. By that, what happens is you can use your SDN controller to program your radio network. Okay? Next, this is the network slicing. So now you have, okay, so I always say when someone asks me 5G, tell me in few words, I just tell them 5G is all about three things: radio, transport, and cloud. Pretty much these are the things: radio, which is radio network, your transport network, and then cloud, right? So this particular diagram depicts that. You have the RAN network, you have the transport SDN, and then you have the packet core, right? Which is essentially, you can treat it to be within the same core data center, or it can be part of the edge cloud. And then all of it would essentially be providing different service, but how is it differentiating? It is differentiating via the concept of network slicing. So network slicing is not just network slicing the network, it is about moving your network functions in and out of your core data center or core cloud into edge and then back. Okay? So as I was starting at the, mentioning at the beginning, intent. Intent is going to be the most, I would say that that's going to be most used word going forward, because everyone of us, we have an intent, or our business has an intent. It's going to be as simple as mentioning my intent, and the network has to be ready. This particular diagram shows what are the open source projects that are available in today's in the LFN that can essentially help me to realize this particular dream. Of course, ONAP is the most important component, wherein it already has a lot of such models to support intent. I'm just showing Open Daylight as an example here. What it means is my controller has to manage three types of network functions: my physical network function, my virtual network function, my cloud native network function. In this particular heterogeneous network function, I mean, the type of network functions is going to stay, right? It's not going to be just cloud native. I mean, to realize just cloud native is going to take some years, right? But some people would confuse themselves. If I say PNF, they would always think as legacy. No, it's not. I'm not talking about legacy. It's about physical devices. It can be a radio antenna, right? But nevertheless, what we are trying to say here is you need to be dealing with different types of components, different types of network functions, okay? And then, okay, here is, I'm getting into the real topic, which is essentially how is that we are going to realize that. This is just an analogy. What we do when we buy a car. For example, if you're a family of, I mean, if you're just married, you would probably buy a nice car, a convertible, high-speed car, right? Then when you have a family, then you probably look at a minivan, right? And then if you're adventurous, you'll probably buy a bike, right? So each one of it is all static investment. It's just an analogy, okay? But the use cases are quite dynamic, and then it keeps changing. For example, I will share from my personal experience. So when I moved in here, I was thinking, okay, I should be happy. My thing is, okay, a car for probably 2, or with my parents 4, it should be good. So probably a Toyota Camry or Honda Accord should be good, right? Then kids came in and said, oh, what do we do? I went in for a minivan. Now I'm becoming more adventurous. Both of these cars doesn't suit my needs, right? Which means that you're not reusing your investment, right? You make one decision, and you, in a way, I mean, from my example, I would say that I convert my minivan, I remove all the seats, and then use it as a cargo, but I have my own set of issues, right? The car gets damaged, right? But if I have a chance, if I was able to compose, if these interfaces were quite open, what I would do, I would probably buy depending upon my needs, right? Depending upon what I want to use, I'll compose it, which means I'm buying the components and assembling it. In today's world, that's what is happening, right? The open source is essentially helping you to essentially invest on certain things and you're going to reuse. It's not like one vendor comes in, of course the model is there, but then you see the paradigm shift, right? But is it enough? Okay, just to show, I've composed this and I'm driving in a desert, so it's based on the same components what I bought, I composed this particular car, right? Let's move on. This reality. Quick question. How many of you have heard of pets versus cattle? What does it mean? How do you take care of your pet? Special care. I see a lot of spa coming around. Spa for pets. They are integral part of you. So when you go like 5 years or 10 years, when I buy a new server, I look at it, I take care of it, I treat it with special care. My first planning is I go and tell my construction company, hey, I would have a lab. It has to host any device, any vendor device. This is the power consumption, this is the cooling I need, right? But now we are talking about, so this example shows that this is your network or your infrastructure, right? These are the different network services, and these are your servers. Don't you see that these look like cattle? Right? So what I do, I have my intern, I'll go and pick up this network service, compose it, and provide it to you. The most important thing you would ask, hey, is the hardware ready? Yes, hardware are also becoming quite composable. There are quite different types of architecture. For example, the most common thing that is known as hyper-converged, right? Or rack scale architecture, right? So what I'm trying to picture is that we are moving towards that direction, right? Now let's take a live example. Okay, so I'm jumping guns. I'm basically using Kubernetes. So the intent is, hey, I want to set up a fixed baseband for X customers. What do I have? If you're familiar with Kubernetes, you define all of these services, and then the YAML essentially shows where do I pull in this functionality, which means in this diagram, one of the network services are nothing but it might be BNG, AAA, DHCP, DNS, gateway. I'll pull off all of those. And then Kubernetes essentially through this would essentially schedule it. You can say what is your current state and what is your desired state, and boom, you have your infrastructure composed. Right? Now, as we speak, Kubernetes is being thought of to support only these type of constructs, which is essentially config map, secrets, deployment, stateful sets. But let's assume I have my own type of resource. How do I do it? How do I make Kubernetes to schedule it? Right? That is where the concept of custom resource definition comes in. What is a custom resource definition? A custom resource definition is that I have my own resource definition, and I want Kubernetes to schedule it. Why do you need that? When Kubernetes schedules whatever the construct that has been defined by Kubernetes, the definition is all predefined. It knows how to schedule a pod. It knows how to schedule it. Let's assume that you're scheduling a network service. what is important here. For example, if you want a near line scale, if you want really high throughput, what do you need? You'd probably look at hardware acceleration. I would then need to schedule it in an SRIOV or a SmartNIC-based server. I need to treat it in a bit different. Probably Kubernetes may not have the knowledge to understand it. What it means by that, it would need to probably define that network as a parameter. With custom controller, you can do so, which means when you schedule, Kubernetes understands that the constraint is not just compute, memory, storage. I also need to look at my network. That is on the controller part. On the resource definition part, you would essentially look at, these are my resource. I'm defining it. This is how it has to be composed, which means Kubernetes can schedule it based on that. Okay? So the whole concept here is start looking at Kubernetes to be your one-stop solution for composing your whole infrastructure. Okay? With that, let me get into a concept called network service mesh. This is close to my heart. Okay? Yes. Okay. So when Kubernetes started, they did not open up. They just had a concept called, for resource definition, they had a concept called third-party resource, TPR. Okay? But now it has, in this 2 or 3 years of journey, they have essentially got feedback from that of the end users or the users. And then what they have done is they have started opening up the APIs, which means the controller can be extended using the constructs provided by Kubernetes. Right? It's all the constructs that are provided by Kubernetes. Nothing new I'm adding in order to make the change. Okay? So it might quite sound abstract, right? So that is where I thought I'll probably get into an example, a real-life example, to show how the journey would be and how you can build your own Kubernetes CRDs. Okay? Let me pause here for a second and open up for questions, some questions before I can get into the concept. Yes?
As you know, in ONAP, right, instead of using ODL as a controller, they're using REN, right, intelligent controller, which is a separate controller that's built to address latency requirement that controller needs to serve to support 5G requirements, right? So how do you plan to address those kind of enterprise requirements to build a 5G network?
Okay, so the reason I showed you is just to give an example. The reason is, of course, there are different school of thoughts with respect to, I would say, Open Daylight. But Open Daylight, when it started, we were looking at composability as the most important thing. Okay? The reason is, we wanted to create, because I've been associated with Open Daylight probably more than since its inception, 5 years. And what has happened is, there is no single SDN controller that can address multiple type of southbound devices. So that is where it is bulky, and it has, we call it as an MD-SAL, right? It is model-driven, service abstraction layer. What is abstraction layer is? It abstracts, right? You essentially have a tree, you populate it, depending upon the tree chain, you can essentially go and program it, right? Now, I fully agree with you, but so the whole concept, what I'm trying to explain here is, you can look at these components as possible things, but the central theme of this talk is essentially to look at how you can compose your infrastructure. That's the central theme. So to further explain you, I'm going to talk about network service mesh, right? The concept here is, until now, most of the networks have been built based on old school of thought. What is the old school of thought? The OSI layer, right? I have my L2, L3, L4 to L7, right? But now things are changing, right? So now is the time where you also start looking at networks or the network functions as services, right? To add to your question, right? Now you have mentioned that you're suggesting that Open Daylight can be used. No, I'm not suggesting. I'm saying it is an example. You are talking about a specific controller that was able to provide you what the a real-time experience what OpenR interface or ORAN needs. I would say ORAN, it's not OpenR interface, right? Now the question here is, I can put in any controller what I want, but if I can open up the interfaces, if I can define my endpoints, my APIs, I can seamlessly pull out and pull in, right? In a composable architecture, the moment you are following microservices, which is essentially API-driven, and if you follow the 12-factor app, which is a well-known thing, you would essentially ensure that there is no tighter integration between the microservices, right? So if you follow those principles, that is where you will be able to realize. Otherwise, your infrastructure would continue to be static. That's my message here, okay? With that, any other questions before I jump into the concept of network service mesh? Okay. So I think we are running out of time. So let me quickly show you. So network service mesh, what we do is we are essentially exposing network services as a service, which means the service can come out, they can publish their endpoints, and then any client can connect to that of this service by looking up into the service registry and then getting those information. This particular thing was built using the CRD concept, and just to show you, so here you see the kind is network service, which means this is a new type of resource definition in Kubernetes, and Kubernetes knows how to schedule it. This is the live example. And I have a demo at the Elephant booth. Please walk by, I can explain you further. But the idea here is showcasing network service mesh to be an example of CRD, okay? This is integrating ODL. So also what we are trying to look at is, this is an example wherein you can start looking at Kubernetes as your network services orchestrator. And here, as you see Kubernetes API as a CRD, right? And then by that, what happens is I can essentially compose or schedule or perform operations depending upon what I want, right? This is just a quick snapshot about what are the various things. We talk about monitoring via the Prometheus, auto-healing via replica set, and as you see, the Kubernetes API CRD can be used to dispatch those changes, okay? So I'll probably end this with this quick chart that shows a maturity of any organization. We started with virtualization, where it provided you lower CapEx and OpEx. We got into normalization, wherein the service abstraction was brought in, and then this provided, since it is abstracted, it provided a bit of freedom of choice. I can bring in any solution. We got into programmability, which essentially made, I can have more like a canary type of deployment. I can essentially test my components. Then orchestration essentially helped you to reduce the dependency in human. That is what is expected. Eventually, when you have so many microservices, when you have so many cattles, there has to be a loopback, closed loopback system wherein the system can itself understand what is the problem and try to solve it. That is where the whole concept of auto-healing and self-organizing network comes in. And finally, predictability, wherein you should be able to, depending upon the pattern, you should be able to predict and then program your network, okay? Or reprogram your network so that you can avoid faults. With that, I just want to show you, this is from Lumina, and we have a platform that tries to address most of the components of 5G, including network slicing. Yep, thank you. I think I ran out of time. So I'll be at the Elephant booth. Please pass by if you have any questions. But thank you. Thanks for listening. Thanks.